Okay, let's do a force review to get ready for um, just to kind of know what's going on in the world of forces. Remember, it's one of the 6 units that we're going to cover, and then we're going to talk about the 4 different systems. Force really is why things happen in the mechanical world and electrical world and thermal world and fluid world. Why do things happen? So first of all, we need to understand that it really is the why. Now, to understand it, we have to talk about our 4 different systems. In mechanical, the reason things happen is due to an unbalanced force. And the key thing, it's got to be an unbalanced force or an unbalanced torque. Could be either one is the reason things happen in a mechanical system. So these are what we call the prime movers. It's the reason things happen. Now, in a thermal system, it's due to a difference in temperature. Heat is always going to flow from hot to cold, probably the single most important thing to understand with heat energy. It's always going to flow from hot to cold. Never can go the other way. Things become cold because they lose heat. In the electrical system, it's due to voltages. It's due to a voltage difference, and we won't always say that, but there always has to be a voltage difference or voltage drop in order for something like that to happen. And that voltage is going to cause electrons to move. It's the reason electrons move. They're not going to move on their own. We have to cause them to move. And voltage is the driver. It's what causes it to happen. In fluid systems, it's a difference in pressure, and it's always going to go from high pressure to low pressure. Air leaks out of a balloon because it's higher pressure inside the balloon than outside the balloon. It will leak out until it's equal. Now, let's take a look at let's go equations. There's not really as many equations for this, but there's still a few, and also units. So first of all, let's cover our 4 systems. In mechanical, there's not really an equation for linear force. There is 2 different types. There's linear and rotational. Linear means straight line. Rotational means obviously spinning. It's just there has to be an unbalanced force. An unbalanced force is going to lead to acceleration. Now, the units, well, they're pounds and newtons. Pounds in the English system, newtons in the metric system. For rotational, there is a formula. Torque is equal to force times lever arm. Now remember, the bigger the lever arm, the more torque you can generate. That's why if you're going to chop down a tree, you grab a big axe. You don't go do it with a hatchet. It would take too long. The lever arm is bigger, so that makes a difference. Now units, well, in the metric system, it's going to be units of force times units of distance. We generally are going to write that foot-pounds of torque. And units of force times units of distance in the metric system would be newtons times meters. Now for the thermal system, the 2 units we use are Fahrenheit and Celsius. Those are the 2. Now you will have to go back and forth between the 2, but they're going to give you the equation. You just got to plug and chug and get it done. Now, in the electrical system, we have to understand volts. And more about that later, but it's the reason things happen in an electrical system. Also under this, there's 2 simple things. There's a series circuit and a parallel circuit. Series means one path. The voltages add up. Parallel means multiple paths, and the voltage is the same. So if you have it. The last thing is in a fluid system. A fluid system does have a formula for it. Pressure is equal to force over area. Remember, you don't have to memorize formulas, but you do have to be able to use them. There's also a number with this we need to know, 14.7 pounds per inch squared, PSI. That's what it normally is in the English system, and that's a number you're going to hear a lot. Since pressure is force over area, there's 2 different units. Well, pounds per inch squared is the English unit. The unit of force would be newtons per meter squared, which is also called a Pascal in the metric system. Now let's make sure there's a couple other topics that we need to make sure that we, and words that we need to understand. First of all, in the mechanical system, unbalanced forces cause acceleration. Now notice how I said that I didn't say they cause movement. They cause a change in movement. Also in here we need to understand the difference between scalar and vector. Scalar is a number only. Vector is a number and a direction. So for example, forces are always vector quantities, because they have to have a direction. Something like time would always be a scalar quantity because it doesn't mean anything. So for example, things like weight, well, weight always acts down, so whether we say it or not, there's a direction there. Acceleration, there's a direction on acceleration. Also the word equilibrium. Equilibrium simply means equal. Captain Obvious. Equal forces, equal temperatures, equal pressure. Don't let that word throw you. It's a 50-cent word. Now, for fluid forces, there's a term that comes up a lot in this course that we need to understand, which is weight density. Weight density is nothing more than the pounds per feet cubed. Traditionally, when we talk about normal density, we go mass over volume. Weight density is nothing more than weight over volume. So this is our traditional density. This is weight density. So it's going to be feet per second for pound per feet cubed. This is going to be newtons per meter cubed, something like that. Weight density is useful if you determine the pressure of something underneath a fluid. Also under fluids are specific gravity. Specific gravity is essentially density without units. Also with density, remember, we compare everything to water. Water has a density of 1, density greater than 1. If density is greater than 1, it sinks. Density less than 1, it floats. Now under electrical force, batteries. You're going to see a battery question. Batteries look like that. There's a positive end and a negative end. The negative end is called the anode. It's got an N in it. The other end is the cathode. And you'll see those terms as you go on in electricity and stuff like that. Also, batteries are DC because they always have positive and negative marked all the time. Your wall socket is AC because what happens with your wall socket is it continually changes. Those two change. It changes from positive to negative to positive to negative to positive to negative continuously. Continually alternates. And finally, thermal. One thing is important to understand with that is the difference between Celsius degrees and degrees Celsius. This is a temperature. So we say it's 68 degrees Celsius. This is a change in temperature. The temperature rose by 68 Celsius degrees. If you say it out loud, it's kind of easier, I think, to follow it. So that's kind of all the stuff on force that you're going to be responsible for and all that. Just kind of a quick overview, review of it. You need to know all that stuff.